Welcome back. Previously, we described how to use the target mean as a proxy to determine if a feature is important or not. We followed a method that was used in a KDD competition in 2009, and what they did is basically replace the categories of categorical variables by the target mean and use that as a prediction, so utilizing that encoding with the target to determine a metric, for example the ROC-AUC, to see if this was a predictive feature. And for numerical variables, the procedure was the same, it just involved a step of discretization to sort the continuous values into intervals before encoding with the target mean. We did this manually, but now we can also do this utilizing Feature Engine. To do this, we need to import from Feature Engine selection the SelectByTargetMeanPerformance transformer. As always, we load a dataset. This transformer works for numerical and categorical variables. This is one advantage of this procedure, because most transformers would work only for numerical variables. So we're going to load the Titanic dataset that has a mix of both numerical and categorical variables. Here I do some transformation to create suitable variables for this demonstration. From the variable cabin, we retain only the first letter, and we remove rare values. So these are the categories of the cabin variable. And here we can count how many observations we have per category. We can also count how many observations we have for each value of the parent or child variable, which is numeric, but we're going to work with it as if it was categorical. And we can see that most observations show values 0, 1, and 2. So we're going to cap this variable at 3. For values bigger than 3, we will replace the original value by the number 3. And we do the same for the other variable, sibling or spouse, which also shows most observations with values 0, 1, or 2, so we're going to also cap it at 3. We're going to work with the variables p-class, sibling or spouse, and parent or child as if they were categorical. So in order to use Feature Engine, we need to recast them as if they were object. And then we go ahead and separate the data into train and test. Now we can select the features utilizing the SelectByTargetMeanPerformance. If we set variables to none, the transformer will check all the variables in the dataset, categorical and numerical. Because this is a classification problem, we set up the scoring as the ROC-AUC score. The threshold is the minimum ROC-AUC value that the feature needs to show in order to be selected. And for numerical variables, we say that we want to sort the continuous values into 3 intervals, and we want to build equal frequency intervals, so that is intervals that contain the same percentage of observations. The SelectByTargetMean utilizes cross-validation, so here we indicate the cross-validation fault, and then we set up the random state for reproducibility. With fit, utilizing cross-validation, the transformer encodes categorical variables with the mean of the target, and then utilizes that to determine the ROC-AUC value against the target. Or, for numerical variables, it discretizes into 3 intervals, then replaces the intervals by the mean of the target, and then utilizes that as a prediction to determine the ROC-AUC against the target. This is why, when we fit, we also need to pass the target. This transformer has a couple of attributes that are generated after fit. The first one is the categorical variables, so here we can see which variables were considered categorical by this transformer. And in the variables numerical attribute, we find the numerical variables that were present in the dataset. In the attribute feature performance, we find the ROC-AUC that was determined after encoding the variable with the target mean. And then in features to drop, we find the features that are going to be removed because this ROC-AUC is smaller than the 0.6 threshold that we indicated when we instantiated the transformer. So if we look at age, we see that the ROC-AUC is 0.53, sibling or spouse is 0.57, and so on. So this is why these features are going to be removed. When we apply the transform method, these 4 features are removed from the original dataset. You can check more about these transformers in the feature engine documentation.